Hello, my name is Kristina Isberg and I work at HYdrological, one of the partners in Geoland2. I'm invited here to show you the tools developed within Seawater and their benefits. Geoland2 is funded by the European Commission. The aim is to prepare operational capabilities of the GMS land service, that is satellite data, provide cross-border harmonized geoinformation for 7 core information services. Seawater, one of the service's main purpose, is to provide high-resolution pan-European hydrological model and nutrient management tools to support the implementation of EU directives. Developed tools within Seawater are HYdrological, which serves the models with input data, HYdrological, a pan-European hydrological and nutrient model, HYdrological Web, a web tool for free downloading of data, the NPPS, a non-point pollution service, and finally the nitrogen surplus map. Based on actual agricultural management and farm policies, it is possible to forecast nutrient loads per farm unit using COPRI. In the nitrogen surplus mapping, these results are combined with land use and soil maps. Here you can see the outputs from the mapping. The products may be instrumental for all interested in the impacts of agricultural policy on fertilizer and pesticide consumption and nutrient surplus. These assessments can then be simulated further in HYdrological to determine impacts of agricultural policies on water bodies. In the MPP service, the nitrogen pollution risks are calculated from different diffuse sources based on the Moniris model. The MPP service outputs include documents with overview charts and tables and links to exploration services and scenario calculation. This year, MPPS will be found on the Geoland2 website. HYdrological sets up data for hydrological models for any region by extracting data from global geographic databases, for example, divisions into subbasins and links between them. Subbasins, characteristics, and forcing data. HYdrological is a pan-European application of the HYDRO model. The domain of HYDRological is divided into 35,000 subbasins. Here you can see some example of possible outputs: snow depth, groundwater level, river flow, nutrients, etc. The outputs can be tailored for users. With the HYDRological web, it is possible to click on any of the subbasins for free downloading of daily and monthly time series. It develops continuously. This year we are planning to add nutrient, forecasts and climate projections. You may find this tool on HYdrological website. So, what can HYDRological be used for? Well, the results can be used to look at flood and drought frequency or intensity, effects on water resources and hydropower, etc. For water quality, we can examine hotspots for nutrient loading or use source apportionment to find out the sources of nutrients. HYDRological can also deliver these results for many different timescales: historical data, real-time and forecasts, and future climate impacts. In the near future, we will also make seasonal to decadal predictions of hydrology. Here is an output from a future climate scenario for European flooding, simulated by HYDRological. Streams and rivers from which a flooding indice will increase by more than 30% are here colored red. This indicates hotspots where flooding is likely to become an issue in the future. HYDRological is already operational at HYdrological, producing real-time hydrological data for all of Europe, and forecasts of up to 10 days. This data is currently used by other institutes as input data to ocean models, but we welcome interested new users. The Baltic Sea is here modeled for identifying nutrient hotspots and pollution sources. It is possible to find out where the nitrogen concentrations are the highest, for example here in Denmark. It is also possible to find out which source that contributes the most, in this case agriculture. HYDRological can also be used for local assessment. An interactive web user tool has been developed within Sudplan. Here you can select a catchment, use own data, and then the system recalibrate for you. This improves the local applications. The user can then evaluate the hydrological consequences of different local land use and urbanization for present and future climate conditions. Here is a list of the benefits and innovation of eHyp. Foremost, the system is very flexible and can easily be used by many water sectors, for many regions and at many timescales. The outputs from eHyp can easily be tailored for new individual applications. Here are some current and potential uses of eHyp. Local fitting of the model can make it interesting to more local users as well. Marine institutes are most frequent users, but we have interest and support from emergency services, cities and counties, hydropower, and energy sectors. We welcome new users and new applications for the products. Thank you for your attention. If you have any questions, I will help you at the SBI water stand.